Hello, everyone. I would like to say thank you very much for this opportunity. My name is Ahmad Sofyan, and today I would like to present my journal. The topic is about the heat loss effect analysis by using JIWAFlow Wellbore simulation in Geothermal well. My presentation will be divided into few parts. First, we'll talk about the outer profile, and then we'll talk about the background, and the next is about the methods of the research, and the fourth one is about the result, and number 5 is about the conclusion. So I will move on to the first slide. My name is Ahmad Sofyan. Right now I'm a PhD student at Department of Mineralogy, Geochemistry and Petrology, Faculty of Science and Informatics, University of Szeged, Hungary. My educational background as a Master of Petroleum Engineering from Bandung Institute of Technology in Indonesia. Currently, I'm working in the Ministry of Energy and Mineral Resources of Republic Indonesia. In the geothermal production system, there is a fluid movement in the wellbore that has an effect to the heat transfer because of the temperature difference in geothermal fluid and the formation. The heat is distributed from the geothermal fluid to the casing, cement, and the formation by the convection and conduction system. There are some methods that have been developed to identify the effect of heat loss present in the wellbore. This research method is by modeling the heat loss effect through numerical simulations with a wellbore simulator to simulate the pressure, enthalpy, and fluid behavior in the wellbore geothermal well. In this research, I use a new simulator developed by PT I5, namely JIWAFlow. Here are some superiority of JIWAFlow compared to the other simulator. First, in the software, no need installation as its web apps with cloud computing system. We can access it by laptop or Android with friendly interface. First, to perform probabilistic accounting with Monte Carlo simulation, integrated to 6 pressure drop correlations, and perform multi-component effect on productions like natrium chloride, CO2, and our topic today is the heat loss. So the objectives in this research is to simulate the wellbore profile from the interpreted PTS survey, generating its output curve, and finally seeing the effect of heat loss on productivity of the well based on the parameter in the geothermal well. In the flow process, there are two main concerns. Of course, after collecting the data and do the literature study, first, we are running the general simulations, then we will running it again with the heat loss consideration. And of course, for the validations, we need pressure temperature validations to make sure that the data is run good and precise enough. And in this wellbore simulator, we use some task parameter. First, for the task feature, we use the production full curve. And for the pressure drop correlation, we use the homogeneous. For the approach method, we use deterministic. And for the auxiliary data, we use the heat loss considerations. And the amount of data we are running for scenario for the 1 baseline case and 3 flow time varied case by 8 hours, 3 days, and 7 days. And the data that we input into the JIWAFlow, first we have the well trajectory, which is conclude of the measurement depth and angle. We also put the data of the casing design, which is have a casing type, the casing size, and also the casing depth. And then the feed zone parameter as well. We have a depth, the pressure, the enthalpy, and also the productivity index of the feed zones. And also for the operation conditions, we have a wellhead pressure, separator pressure, SSC, and SBC. And then for the auxiliary data, we use shut-in temperature, rock formation data, and the flowing time. And this is a comparison graph between the pressure temperature profile measured curve and the model which is simulated by JIWAFlow system. So after running into the simulations, the first output that generated from JIWAFlow system is a Wellbore profile and also the productivity output curve. So from this profile, to make sure that the model is validated and precise, we carry out pressure and temperature matching between the interpreted data of the pressure temperature from PTS and the PT model. So as we can see here that there is a matching between the model and the measure. So the software is precise. And then this is the Wellbore profile that has been generated from the Wellbore simulator. From the table that has been generated from the simulator, we can infer the dryness indicated that the reservoir is a water-dominated system, and the multi-feed zone existence give a fluctuations to the enthalpy and mass flow, as the shallow feed zones dryness is higher for the flow rate and the enthalpy. And as it is a homogeneous model, we could see that this geothermal reservoir is in the two phase with the dryness below 46%. And then from this output curve, we can conclude that the smaller wellhead pressure, the bigger the flow rate would be. And we can see in here also the mass with the wellhead pressure, the brine with the wellhead pressure, and the steam with the wellhead pressure, and also the enthalpy. As we can see that the enthalpy related to the wellhead pressure is a most constant, and there is no like significant changes. And this is the comparison curve of enthalpy that consists of no heat loss, account, and every flowing time variation in every depth measured. The enthalpy in deep feed zone and wellhead pressure occurred showed clearly that the heat loss present mostly at early flowing only and decreasing gradually the longer it produces. And this is the graph of the heat loss effect production curve. And we can see is the effect of heat loss to well productivity. The heat loss present will reduce the productivity, especially the highest effect in the early stage of 8 hours flowing time. These conditions will gradually increase, approaching the baseline of productivity curve, which is not considering the heat loss for 3 days and 7 days flowing time consecutively. Heat loss effect on productivity is not too significant, as we can see in the difference on the curve is quite small. The curve from the earlier time to the longer production time also seem to be gradually approaching the curve with no heat loss consideration as the baseline. So we are in the final slide of my presentations. So we can conclude that first, the correlation method used, the homogeneous, is precise because the fluid in the wellbore has entered the two-phase condition. And secondly, the result of the effect analysis of heat loss illustrates that the most heat loss effect present at the beginning of the flowing time during the compression test and decreases gradually. And then the effect of the heat loss in the wellbore is not significantly influenced in the system when the well production is running in a very longer period. At a wellhead pressure of 26 bar as the production operation point, the total mass flow increased from 8 hours to 7 days, which is from 111.03 to 111.08 kilogram per second. And the enthalpy also increased from 1,798.24 to 1,803.4 kilojoule per kilogram. And the highest mass flow and enthalpy under condition without considering the effect of heat loss are 111.12 kilogram per second and 1,808.2 kilojoule per kilogram. So this is the end of my presentations. If you have any questions, don't hesitate to ask. Thank you very much for all your attention.